All right, so what we'll cover, indexing, why it's necessary, and number two, how Google makes it faster, and then some details about Google's actual indexing system. So, number one, Google is fast. It's really fast. We've done some demos in class, and the search results, typically are around 0.4 to 0.8 seconds. We did a thing in this course where we looked for Joker show times, and it was an absurdly slow 1.75 seconds. I'm not sure why, but, popular searches on Google, about half a second typically. Unusual search might take a second, maybe two. Apparently, like I said, Joker show times, they must have to connect to a lot of external databases to find real-time information. It's a bit slower. Anyway, this is especially impressive because the volume of data keeps growing, right? All the time, there's more pages needing to be ranked. There's more content per page, which complicates the ranking process. And there's more users spending more time on the internet generating more content, generating more search traffic. So everything on the internet, there's just that much more of it. So how does Google keep up? Well, indexing. Go figure. Okay. So what is indexing? Well, remember, Google works by matching search terms to web page content starting with text. So Google has this massive index of search terms and the pages containing them. So at a very small scale, suppose we have this. Suppose we have the word syzygy stored in pages A, B, C, and D. And we have the word zygoma stored in pages B, E, F, and G. And then ziziva stored in pages A, C, F, H, I, J, and K. Okay, so if a user enters those search terms, Google can quickly retrieve the pages containing them, right? It doesn't have to look through the whole trillions of pages. It can just say, oh, there's this very short list of pages that has them. I'm going to grab these. I'm going to rank them. I'm going to deliver the top few hundred. Okay? So once the pages get selected, Google applies the ranking algorithm to determine which are delivered. So when Googlebot scans a page, it basically captures the words, right? It looks at each word in the page, and then the page gets inserted into the various index entries. So you'll have a set of terms and it'll say, oh, this index term is associated with this page and this page and this page. And anytime a Googlebot finds a page that is newly associated with an index term, that's one more that gets added onto the list. Okay? Now, we can already see there's some interesting problems here. For example, the words syzygy and zygoma appear both on page B. But the words syzygy and ziziva both appear on page A. So, what's the preference, right? None of them appear to be on all three pages. So if I search for all three terms at once, what should the ranking be? Well, we don't have enough information. We have to use some kind of context to figure that out. Okay. So, why indexing is necessary? Well, short version, a little bit of overhead processing will save a lot of real-time processing when people are actually doing the search. So, human example. Suppose you had a stack of books and you wanted to find which of those books, if any, reference Charles Babbage. Okay, Charles Babbage, famous 19th century, sort of a pre-computer guy. And suppose further, like a computer, you have no idea who he is or how he relates to book titles, right? It's just a couple words and you have no idea what this means. So, again, very slow approach. You could read each book from start to finish, okay? But you wouldn't want to do this. But very fast approach, for each book, look at the index and see if it somehow mentions Charles or Babbage or Charles Babbage or Babbage, comma, Charles, right? Try to find it in that way. Okay. We talk a little more about distribution. So, suppose the stack of books is very large, and like most humans, you have only one set of eyes, so you're only going to look at one book at a time. Then, even an index search could be pretty slow, right? If the stack of books is big enough, you don't want to do it all by yourself. So, the solution, get a bunch of your buddies, right? Get n people, split the big book stack into n substacks, and each person searches one substack. Essentially, this is what Google does with servers, right? If you have an operation that's very long and tedious to do on one machine, guess what? Google's going to break up that task into tens of thousands of subtasks and assign one subtask to each server. So the total work remains the same. You're still searching through that entire list of books. There's no way, there's no real way to get around that, but the results are obtained n times faster. So to people on the outside, you think, wow, this is going really fast. Okay. Again, this is like indexing in a distributed system. So if you have a large index entry, which might reference millions and millions, even billions of pages, that index entry is going to be broken up onto multiple machines. And then each machine does a small portion of the total work of grabbing the pages and ranking them. Okay. So, we'll extend it a little more. So, suppose your search applications become popular, you have millions of search requests every day, and a few of those searches are very, very common. Most of them much less so, but you have a few that are very common. And then suppose one of your people is super fast, right? Basically, one of your people is RAM compared to the rest of your people being hard drives. So, this person can remember all the results from, say, 100 searches, right? He has good capacity, but it's still finite. But those 100 searches can retrieve the results instantly. So, first execution of a search happens normally, but any subsequent executions are instantaneous. Well, the best way to use that talent would be to have this guy with, perfect recall and high speed deliver the most popular request, right? That way, number one, you make the most people happy in the short term, and number two, you minimize the load on the rest of the system. So, again, analogous to caching results in RAM for the most popular searches. Excuse me. Okay. Well, we'll talk about one more thing. Very simple little bit of math here. Okay. So suppose Google is processing a search that retrieves 100 million pages, okay? When Google gets the pages, it has to rank them. Now, let's ask this on top of this, put this in the middle. Each server in the process has to look at and rank. I guess I do want this after. Okay, so each server has to look at, let's say, 1 million pages, okay? When Google gets the pages, it has to rank them. So, here's the key question. If each server, if the total search results are 400 pages, hypothetically, how many pages would each server need to return to ensure the best 400 results are returned? Okay, so I have a bunch of servers. I have 100 servers in this case. I know Google's only going to give 400 search results, right? It gives me that whole list. It says there's 100 million matches, but I know Google's only actually going to deliver 400. How many does each server need to deliver? It's a much simpler question than you might think. Doesn't even really require any math. If I know that I'm only ever going to see the best 400 results, each server only needs to deliver its best 400 results, right? Best 400 closest matches. Okay? If each server delivers its closest 400 matches, then Google is going to be able to absolutely, with metaphysical certitude, deliver the best 400 matching results to me. Okay? You might, in practice, not even need that many. Since we have 100 servers, maybe even if each server sends back 40 matches, I get 4,000 best-ish results, which probably contain all 400, and certainly must contain the best 40 results. Okay, which is still, I'm perfect through the first 4 pages of search results. That's probably fine. Okay? So, the point is, even though there's a vast number of pages, the processing on ranking This can happen, but this can happen very quickly in RAM, okay, on each server locally. And then as far as delivering the data, I only need to deliver a tiny slice of that data, right? I don't need to deliver the gigs of page data that might be matched. I just go blurp, here's like, you know, like a single packet of page references, and you find them, okay? All right, so simple problem there, but this is a little bit of the architecture, how Google keeps things simple, but still delivers good search results. All right, this seems like a good break point because you're all going away for the weekend.